Hi and Assalamualaikum everyone. Today, we would like to show you application of Newton's second law in cable pulley machine. We are from CDCS 143 and our class is JCDCS 143 4E and our course code is MAT272. Before we dive in, we would like to introduce ourselves first. My name is Muhammad Ifan Ashraf and my student ID is 20244-37022.
My name is Muhammad Adam Mukris bin Effendi Jasna and my ID number is 2024403982.
My name is Jericho Edri bin Josni alias Joseph and my student ID is 2024652662.
Hello, my name is Muhammad Nazari bin Muhammad Kamari. My matrix number is 2024-213-796.
Now, moving on to introduction. Newton's second law states that the net force acting on an object is equal to the product of its mass and acceleration, expressed as a sum of F equals to ma. This law explains how an object motion changes when a force is applied. One important application of this principle is in a cable pulley machine, where forces such as tension and weight determines the movement of the connected objects. Cable pulley systems are commonly used in elevators, cranes, construction sites, factories, and gyms equipment to lift and move heavy loads efficiently. By applying the Newton's second law, engineers can calculate the acceleration of the system and the tension in the cable, ensuring that the pulley systems operate safely and effectively. Now, our purpose of study is one practical application of Newton's second law in everyday life is in the cable pulley machine found in gym equipment, widely used in strength training. This system generates an acceleration and tension force that acts directly on the user's muscles and tendons. Studies have shown that muscles or tendons injuries are the most common type of gym-related injury, often caused by inappropriate loading. Without accurate calculation, trainers find it difficult to determine a safe load, making it harder to design an effective progressive overload program. Therefore, understanding and calculating the acceleration systems and tension force through Newton's second law is essential to ensure safe and effective training.
Here's our first problem statement. Mr. Ashraf is a personal trainer at a gym who wants to train a new member, Aiman, using a cable pulley machine as shown in figure 1. The machine consists of a weight stack of mass 45 kg connected by a light inextensible cable that runs over a frictionless pulley mounted at the top of the machine frame down to a handlebar of mass 1 kg that Aiman holds and pulls. Aiman pulls the handlebar downward with an applied force of 500 Newton. Determine the tension force P in the cable and the acceleration A of the system to evaluate whether Aiman's applied force is sufficient to safely and effectively lift the 45 kg weight stack.
So, solution for this problem is I would like to draw the free body diagram first, which we have two. Free body diagram 1 for the weight stack and free body diagram 2 for the pulling force applied by Aiman. Then, based on the free body diagrams, we formulated the equations using formula total force equal to mass multiplied by acceleration. For free body diagram 1, we get T equal to 45A plus 45G and set it as equation 1. And for free body diagram 2, we get T equal to 500N plus 1G minus 1A and set it as equation 2. Then, we find the acceleration by comparing equation 1 and 2 since both is equal to T. And we get 45A plus 45G equal to 500N plus 1G minus 1A. Then, we let the A on the right side and the G and N on the left side to do the calculations. And we will get the acceleration is equal to 1.861 meters per second square. Then, we substitute the A value to the equation 1 or 2 to find the value of tension, which is T. I would like to substitute it to equation 2. And we will get the value of tension is 508.32 N. Therefore, since the acceleration is positive, we can conclude that Aiman can pull the weight stack successfully.
Second problem statement. Mr. Ashraf now wants to test a heavier setting on the same cable pulley machine as shown in figure 2. The weight stack is increased to 60 kg, still connected by the same light inextensible cable running over the frictionless pulley, down to the same handlebar of mass 1 kg that Aiman holds and pulls. Aiman pulls the handlebar downward with the same applied force of 500 Newton. Determine the tension force T in the cable of this and the acceleration A of the system to evaluate whether Aiman applied force is still sufficient to safely and effectively lift the 60 kg weight stack.
Solution for problem statement 2 is based on the given problem statement. The information provided includes the force applied by Mr. Aiman, which is 500 Newton. The weight stack is 60 kg and the handlebar is 1 kg. The objective is to determine the tension in the cable T and the acceleration A of the system. The first step is to draw two free body diagrams and label them to FBD1 and FBD2. For FBD1, apply Newton's second law using the equation sum of F equal to MA and substitute the given values into the equation. This produces the first equation relating the unknown variables. Next, repeat the same process for FBD2 by applying sum of F equal to MA and substituting the given information into the equations gives the second equation. After obtaining both equations, rearrange the equation from FBD1 to make T the subject. Then, substitute this expression for T into the equation from FBD2. Solving the resulting equation gives the value of the acceleration. Finally, substitute the calculated value of A into either of the two equations to determine the tension in the cable. The final results show that the tension in the cable is 511.2 Newton, while the acceleration is negative 1.29 meter second. The negative sign indicates that the actual direction of acceleration is opposite to the initially assumed direction in the free body diagrams. Therefore, Aiman cannot pull the weight stack because the force that Aiman pulled is less than the weight.
In conclusion, the cable pulley machine demonstrates Newton's second law of motion, where the accelerations of an object depends on the total force acting on it and its mass. When the load weight is greater than the pulling force, the acceleration is negative, indicating that the load accelerates in the downward direction. On the other hand, when the pulling force exceeds the load weight, the acceleration is positive, implying that the load accelerates upward. The calculations show that the direction of the acceleration are determined by the imbalance of the force acting on the system. Therefore, Newton's second law is essential in the design and operation of cable pulley machine, ensuring their efficiency, safety, and reliability during use. That's all from us. Thank you.